Hi there and welcome to another video where we revise the Edexcel Core 3 syllabus. In this particular video I'll go through all the past paper questions on trigonometry that have arisen in regards to the addition and double angle formulae. Okay, as always, pause the video to work through a question, then play my answers and work through my answers marking your work. Here we go, question 1. Okay, part A. You should really know these offhand. However, in the formula booklet you are told that sine of A plus B is equal to the following. It is equal to sine A cos B plus cos A sine B. In particular, if you let A equal B equal X, you would therefore get that sine of X plus X, which is sine of 2X, would be sine x cos x plus cos x sine x, which is actually 2 sine x cos x. So you get that from the formula booklet, but to be honest with you, this is the type of formula that really you should probably have in your head. Okay, part B. You are using the domain x is between 0 and pi. You are asked to find the solutions of this, and you're asked to give your answer to 2 decimal places. We've got cosec and a cos at the moment. Nothing's obvious to do. Translate the cosec into what it means, and then we'll see where we go. In your head, you should be thinking, can I use part A? Why have they asked me to write down sine 2x? We'll see in a second. Now, cosec is 1 over sine. So this translates to 1 over sine x, subtract 8 cos x is equal to 0. Multiply everything by sine x to remove the sine x on denominator. 1 subtract 8 cos x sine x is equal to 0, because 0 times sine x is 0. Now, if you're really clever, and you should be able to do this, you should spot that this is 1 subtract 4, 2 sine x cos x. This here is 4 times 2 sine x cos x. Now, you know from the previous part, there's an expression for this. This is equal to sine of 2x. So this is the same as 1 subtract 4 sine of 2x is equal to 0. Okay, add 4 sine x to both sides. 1 is equal to 4 sine, 2x. Divide both sides by 4. A quarter is equal to sine 2x. Therefore, 2x is the inverse sine of a quarter. With your calculator in radians mode, of course. Okay, so go to your calculator and type in inverse sine, put it in radians mode if it's not, and then type in inverse sine of a quarter. And you get 0.25 radians, so you get that 2x is 0.25 radians. Now let's find the other solutions. Let's draw our graph to find the other solutions. We're looking between 0 and pi, but because we have 2x here, we're going to double that. So we're going to actually look between 0 and 2 pi. Now we know that 0.25 is an answer, 0.25 radians here. So we also know an answer is going to be here, which is the same as pi subtract 0.25. And that would give us 2.89. So another solution is 2.89. There are no other solutions in the range 0 to 2 pi, so these are our only solutions. So what we do is we halve them both to get our final answer, and therefore x is equal to 0.13 and x is equal to 1.44 radians, and they are our answers. Okay, next question. Pause the video, have a go. Right, part A, we're asked to prove the following identity. Let's just start with the left-hand side. So left-hand side, we have sine theta over cos theta plus cos theta over sine theta. We're trying to add fractions. Can't add fractions till the denominator is the same. Multiply top and bottom of this by sine theta. So you would get sine squared theta over cos theta sine theta. And this, multiply top and bottom by cos squared, by cos even, and you would get cos squared theta over cos theta sine theta. Then you could add them, so you would get sine squared theta plus cos squared theta, all divided by cos theta sine theta. Well, the top, sine squared plus cos squared is 1, and the bottom is cos theta sine theta. This is actually equal to a half sine of 2 theta. Because you should know this, you should know that sine 2 theta is 2 cos theta sine theta. So therefore, in particular, cos theta sine theta must be a half of this. And therefore, 1 over a half is 2, and you have 2 over sine 2 theta, which by definition is 2 cosec 2 theta. And you're done. Okay, then it asks you to draw the graph of y is equal to 2 cosec 2 theta. Okay, what I would, so this is the graph y is equal to 2 over sine of 2 theta. Now, firstly, in order to get my head around this, I would just draw the graph of y is equal to cosec of theta. That's the graph of y is 1 over sine theta, before I try and do this. Now, I know that sine theta looks as follows. So 1 over sine theta, quite easily, I can draw, I know it looks one over sine theta ends up looking something like this. Okay, asymptoting at 180, 360. Now, I'm actually drawing 1 over sine of 2 theta. Even 2 over sine of 2 theta, but 1 over sine of 2 theta for now. That is a stretch by a factor of 2, a squash by a factor of 2. So actually, there's going to be a bell-shaped in there, there's going to be another one there, and there's going to be another one here, and another one here. Okay, so I can rub these out here. I also know that I'm multiplying by 2. So where it dipped down at 1, it's actually now going to actually just dip down here at, that's going to be the point 2 there. And it's going to come like this here, and that's going to be the point negative 2. And then it's going to come down like this, and then it's going to go like that. So it was just about thinking about what cosec looked like and then doing a transformation of it. And then it's asking you to solve this given your answer to 1dp. Now in part A, you have said that this is 2 cosec 2 theta. So equivalent to solving this is equal to 3 is solving 2 cosec 2 theta is equal to 3. Divide both sides by 2. Cosec 2 theta is therefore 3 over 2. Cosec is 1 over sine. So flipping this, this must tell us that sine of 2 theta must be 2/3. So 2 theta must be the inverse sine of 2/3. We're solving between 0 and 360. So if you do that on your calculator, the inverse sine of 2/3, and your calculator must be in degrees mode for this, you get 41.8. 2 theta is therefore 41.8 degrees. Let's draw our graph out just to check our other solutions. Now we're looking for solutions between 0 and 360, but because we're dealing with 2 theta, we double this domain, and then so we can halve it at the end. Now our sine graph looks something like this. okay, between 0 and 720. We know there's a solution at 41.8. There'll be one here, there'll be one here, and there'll be one here. This is 41.8. This is obviously 180. Subtract 41.8. This is going to be 360 plus 41.8. And this one is going to be whatever this one was plus 360. So 360 plus, I'm going to call this one alpha. And there's how we found our other solutions. So our next solution therefore is 138.2 degrees. Our last one's going to be 498.2 degrees, and the one in between is going to be 180 subtract 41.8, 41.8 plus 360 is going to be equal to 401.8. So halving everything to find theta. What is theta? Theta is therefore 20.9 degrees, 69.1 degrees, 200.9 degrees, and 249.1 degrees. And they are our answers. Okay, next question. Pause the video, have a go. Okay, in part A, we're asked to show this identity. Okay, easiest thing to do is use the double angle formulae. You should know that sine 2 theta is 2 sine theta cos theta. You should also know that cos 2 theta is equal to 2 cos squared theta subtract 1. Now, you may ask yourself, where did I get that one from? Well, I would expect you should be able to know these ones, but you should know that cos 2 theta is cos squared theta subtract sine squared theta, and then substituting for sine squared theta as 1 minus cos squared, you get this. So if we substitute both of those up here, so the left hand side, well, sine 2 theta is 2 sine theta cos theta. We've got our 1. Cos 2 theta is 2 cos squared subtract 1, so it's plus 2 cos squared theta subtract 1. The 1's cancel, and so do the 2's. So what do we get? This is equal to sine theta cos theta over cos squared, which is cos theta cos theta. These cos thetas cancel, and you get sine theta over cos theta, which is equal to tan theta, which is equal to the right hand side, and that's what you were looking for. Okay, next, part B. Hence find all the values between negative 180 and 180 of this. Now you've done in part A, you've said what sine 2 theta over 1 plus cos 2 theta is. Well, you've nearly said that. So you can use this. This is the same thing as 2 sine 2 theta over 1 plus cos 2 theta is equal to 1. So halving both sides, this is the same as sine 2 theta over 1 plus cos 2 theta equals a half. Well, from part A, this expression here is simply tan theta. So this is the same as solving tan theta is a half. To get the principal value, theta is the inverse tan of a half. So type that in your calculator, inverse tan of a half, keeping your calculator in degrees mode. You get that theta is 26.6 degrees to 1 decimal place. Okay, draw out your tan graph to find all your other solutions. You're going between, here's negative 90 to 90. And here's going to be 90 to 180. And here, you're going to have, here's actually going to be like this. to negative 180. Now, you're trying to find all the solutions. You know 26.6 is a solution here. It's 26. So you know there's another solution, negative 180 plus 26. So the other solution is therefore equal to negative 153.4 degrees. And they are your two solutions. Next question, pause the video, have a go. Okay, first part, you're asked to show the following. Now, start off with the left-hand side. You should know the double angle formula, cos 2x. We could write that as cos squared x subtract sine squared x all over cos x plus sine x. You could notice the top is a difference of two squares, so it's cos x plus sine x multiplied by cos x subtract sine x, a difference of two squares, all over cos x plus sine x. And something useful happens, cos x plus sine x can be cancelled, and you get yourself cos x subtract sine x, which is equal to the right hand side as you are looking for. Part 2, we're asked to show the following. Okay, so what we could do here is again start off on the left hand side. Let's say we would that would expand as a half cos 2x subtract a half sine 2x. We can use the double angle formula here. So we could say, we could say that cos 2x, you should know this, is 2 cos squared single x subtract 1, subtract a half, and sine 2x is 2 sine single x cos x. You should know those substitutions. You should know that cos 2x is equal to that, and you should know that sine 2x is equal to that. We'll be able to derive it very quickly. So expanding these, this would get us that a half times 2 would just simply be cos squared x, a half times negative 1 is negative a half, and negative a half times this is negative sine x cos x. And this is cos squared x subtract sine x cos x, just replacing these, subtract a half, and that is exactly equal to the right hand side as required. Hence or otherwise, show that this equation can be written as the following. So this here, we need to look back and see previous parts. Have we got anything that can help us with this? Well, we know that cos 2x over cos x plus sine x is equal to this here. So cos 2 theta over cos theta plus sine theta, I can rewrite that. So I can rewrite this. I can rewrite that as cos theta subtract sine theta. So I can rewrite this whole thing as cos theta subtract sine theta. So keep the cos theta where it is for now. I can rewrite that as cos theta subtract sine theta is a half. I can rewrite that equation just substituting from the previous part that for my work in the previous part. Now I can expand this and I can say this is cos squared theta subtract cos theta sine theta, and I could take the half from both sides is equal to 0. Oh my, what does that look like? We'll look back in the previous part. This here, cos squared minus cos sine subtract a half is the same as this thing here. So I can write this as the same thing as this equals 0. So I can write that as equal to a half cos 2 theta subtract sine 2 theta equals 0, times both sides by 2, and I would get cos 2 theta subtract sine 2 theta is equal to 0, and add sine 2 theta to both sides. I would get, as required, sine 2 theta is equal to cos 2 theta, and I'm done. And lastly, it's asked us to solve between 0 and 2 pi this here. So what I can do is, to solve that, I can divide both sides by cos 2 theta. and I could get tan 2 theta is equal to 1. Therefore 2 theta is the inverse tan of 1. And the inverse tan of 1 is pi by 4 in exact form. So there's one solution. Let's find the other solutions, leaving your answers in terms of pi. We're looking for solutions between 0 and 2 pi. So because we're dealing with 2 theta here, I'm going to look between 0 and 4 pi. So here that would be pi by 2. This point here would be pi. This point here would be 2 pi. This point here would be 3 pi. And this point coming up here would be 4 pi. Okay, so we know there's a solution at pi by 4, so there'll be one here, and one here. So pi by 4 from all of these roots. So the other one clearly will be pi by 4 plus pi, which is 5 pi by 4. The other one will be pi by 4 plus 2 pi, which is clearly 9 pi by 4. And this one will be 3 pi plus pi by 4, which will be 13 pi by 4. And then to get theta, what we were asked for originally, divide everything by 2, so it'd be pi by 8, 5 pi by 8, 9 pi by 8, and 13 pi by 8, and we've done. Okay, next question, pause the video, have a go. Right, part A, it says use this identity to prove the following. Well, what you can do is you can let A equal B, and therefore you get that cos of 2A would be cos squared A subtract sine squared A. Then you could use the identity that cos squared A is 1 subtract sine squared A, and substitute that in this one's place. So therefore you could write that cos of 2A is 1 subtract sine squared of A, subtract another sine squared of A, and tidying that up you get 1 subtract 2 sine squared A as required. Okay, part B, show that the following is identical to the following. Here's an identity. So a couple of things. Firstly, you should know a formula for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. Secondly, you have in the previous part just worked out a formula for this, and the formula that you've just worked out for that is cos 2 theta is 1 subtract 2 sine squared theta. Substituting those two in, this one in at the green where the green is, this one in where the yellow is, we will hopefully get the left hand side. So you start, so the right hand side. So you start off with the left hand side and you say that's 2 sine theta cos theta, subtract 3, 1 subtract 2 sine squared theta, and then you've got your subtract 3 sine theta plus theta. Okay, tidying that up, that's 4 sine theta cos theta, subtract 3, plus 6 sine squared theta, subtract 3 sine theta plus 3. The negative 3 and the plus 3 cancel each other out, and you have got a factor of sine theta in everything, so you can factorize out a sine theta. There was a sine theta here, here and here, so therefore what are you left with when you do that? Well, you're left with 4 cos theta plus 6 sine theta subtract 3, which is exactly the right hand side as you were trying to show. Okay, part C, express the following in the form r sine theta plus alpha. where r is bigger than 0 and alpha is between 0 and half pi. These are the simple questions we've done previously. So 4 cos theta plus 6 sine theta, I know I'm going to express it in this form, which when I expand out is r sine theta cos alpha plus r cos theta sine alpha. Therefore I know that looking at the cos thetas here, I know that I can write that 4 must be r sine alpha, and looking at the sine thetas here, I know that 6 must be equal to r cos alpha. Therefore r, as it always is the square root of this number squared plus this number, 4 squared plus 6 squared. So if you work that out, it's the square root of 52, which is 2 root 13. So r is 2 square root of 13. And dividing equation 1 by equation 2, you get tan alpha is equal to 4 over 6, which is 2/3. So alpha is the inverse tan of 2/3, which is 33.7. Actually, we want it in radians mode, so make sure your calculator is in radians mode, and it is 0.59. So this would be equal to 0.59 radians. So therefore, in the correct mode, in the correct format, this format, it would be 2 root 13 sine of theta plus 0.59 radians, and you're done. Hence it asks you to solve the following equation. Hence, between 0 and pi, solve the following equation. Okay, so for this here, it says hence solve, so we're going to use our previous parts. At the moment, this looks like nothing in the previous parts. So let's just expand out. 2 sine 2 theta is equal to 3 cos 2 theta plus 3 sine theta, subtract 3. Okay, subtract 3 cos 2 theta from both sides, subtract 3 sine theta from both sides, and add 3 to both sides. We would get 2 sine 2 theta, subtract 3 cos 2 theta, subtract 3 sine theta, plus 3 equals 0. Now that should look like something we've done previously. Looking back, this here looks exactly like this here. So this is equivalent to solving this is equal to 0. So I'm going to just cut that. So solving this equals 0 is equivalent to solving this is equal to 0 from our previous parts. So this, and also this is like solving sine theta. Now this, we have in the part C worked out that in our cos form, or our sine form, I can't remember what it was in our sine form, we worked out that was 2 root 13 sine theta plus 0.59. So this is 2 root 13 sine theta plus 0.59. Subtract 3 is 0. So on the one hand, a set of solutions are sine theta is equal to 0, and on the other hand, a set of solutions are sine theta plus 0.59 would be equal to 3 over 2 root 13. Okay, so you're between 0 and pi, you're not equal to pi, so this gives you a value of theta as 0, and this gives you a value of theta plus 0.59 is the inverse sine of the following, 3 over 2 root 13. So tap that on your calculator. The inverse sine of 3 over 2 root 13, keeping your calculator in radians mode, and you would get yourself 0.429 to 3 significant figures, so that's 0.429. And what other values are there? Well, between 0 and pi, you've got yourself, the sine graph looks like this, and you've got yourself an answer is for this is 0.429. It's somewhere here, So there'll be another answer at pi subtract 0.429. Now when I take away 0.59, it will bring this out of range, so this one will be the only one left. So this one here is pi subtract 0.429, which is 2.71. So our two answers are 4.29 and 2.71 to three significant figures. But then, to work out theta, when I subtract 0.59 away from both, this one becomes not valid, and this one becomes 2.12 radians to three significant figures. And we're done. Question, pause the video, have a go. Okay, first part, we are given that 2 sine theta plus 30 is equal to this. Find the exact value of tan theta. So let's expand both sides. So, rewriting this side, this would be 2 sine theta cos 30 plus 2 cos theta sine 30. That is the same as that side. And then let's do the other side here. We could say that that is equal to cos theta cos 60 subtract sine theta sine 60. That's given in the formula booklet. Okay, well, we should know the following. We should know that cos of 30 is root 3 over 2. So 2 multiplied by root 3 over 2 is root 3. So this would be root 3 sine of theta. Now this here, we've got a 2 times a sine theta, sine 30. Sine 30 is a half, 2 times a half is 1. So this would be plus cos theta. For this part here, cos 60 we should know is a half. So we get that's equal to a half cos theta. And subtract, we should know that sine 60 is root 3 over 2. So this should be subtract root 3 over 2 sine theta. Now all it asks for, not to solve, it asks for the value of tan theta. So if we divide everything through by cos theta, what would we get? Well, we would get root 3 sine over cos, which is tan, plus cos over cos, which is 1, plus a half cos over cos, which is a half, subtract root 3 over 2 sine theta over cos theta, which is tan theta. Now what I can do is I can add root 3 over 2 tan theta to both sides and subtract 1. So I would get root 3 tan theta plus root 3 over 2 tan theta is equal to a half subtract 1. Adding these together, root 3 tan theta plus root 3 over 2 tan theta, that's like 2 root 3 over 2 tan theta plus root 3 over 2 tan theta, which would be 3 root 3 over 2 tan theta is equal to negative a half. And therefore multiplying both sides, or dividing by 3 root 3 over 2 would give me that is the same as multiplying this side here by 2 over 3 root 3. And the 2's would cancel. And I get that tan theta is equal to negative 1 over 3 root 3. And I'd be done. Okay, next part. Use this identity to prove the following. Well, it's quite simple. If I let A equal B, I would get that cos of 2A must therefore be cos squared A subtract sine squared A. But I know that sine squared A is 1 minus cos squared A. So therefore cos of 2A must be 1 minus... Sorry, that isn't the helpful one I wanted. I actually wanted the other version. I actually wanted to say that cos squared A is 1 minus sine squared A. So this would be 1 minus sine squared A subtract sine squared A. So cos of 2A is 1 subtract 2 sine squared A. Done. Next one, hence it says solve this. Well, hence is the key word here. We're between 0 and 2 pi. I'm going to, instead of using cos 2x, presumably best if I use 1 minus sine squared x. So 1 minus sine squared x equals sine x. Add 2 sine squared x to both sides, subtract 1. 0 is 2 sine squared x plus sine x, subtract 1. Can I factorise that? Well, yes I can. It'd be a plus 1 there and a negative 1 there. So therefore, on the one hand, sine x is equal to a half, and on the other hand, sine x is equal to negative 1. We're looking for solutions between 0 and 2 pi. So where are we going to find those? Let's draw the sine graph between 0 and 2 pi. Where is sine equal to a half? Well, it's equal to a half at pi by 6, and pi, subtract pi by 6, which will be 5 pi by 6. And where is it equal to minus 1? Well, it's equal to minus 1 here, which must be 3 pi over 2. So therefore, our solutions are x is equal to pi by 6, 5 pi by 6, and 3 pi by 2. And we're done. Finally, it says, show that sine 2y tan y plus cos 2y is equal to 1 for y between 0 and pi by 2. Okay, all we can really do here is replace sine 2y by, we should know that sine 2y is 2 sine y cos y. We should also know that cos 2y, well, we've done that on previous parts. Cos 2y is 1 subtract 2 sine squared single y, and maybe we can substitute those in, it will help us. So let's substitute in sine 2y as this. Let's substitute in cos 2y as this and see if it helps. So left hand side, it would be 2 sine y cos y times tan y, and tan y is sine y over cos y, plus 1 subtract 2 sine squared y. Now, these two things here, the cos y's would cancel, and you would get yourself 2 sine squared y plus 1 subtract 2 sine squared y, and therefore the 2 sine squareds would cancel, and you would get 1, which is equal to the right hand side, which is what you're looking for. And we'd have got our 15 marks. Next question, pause the video, have a go. Okay, we're told in this question that sine x is equal to 3/5. We're asked to find sec 2x. Sec 2x, let's just write down what it means, is 1 over cos 2x. Now, we should know that cos 2x, one of the double angle formulae for this is 1 minus 2 sine squared x. So sec 2x must be 1 over 1 minus 2 sine squared x, which is 1 over 1 subtract 2, and then 3/5 squared. Simple as that. And if we just type that in our calculator, 1 divided by 1 subtract 2 multiplied by 3/5 squared, we get ourselves 25 over 7. 25 over 7, and that is sec 2x. Done for 4 marks. Next part, prove the following is true. Okay, let's maybe just start off with the left hand side. What's cot 2x mean? Cot 2x is cos 2x over sine 2x. What's cosec 2x? Well, cosec 2x is 1 over sine 2x. Okay, we can add these because the denominators are the same. So that's cos 2x plus 1 all over sine 2x. Okay, now could we write cos 2x in any helpful form? Well, we could write cos 2x as 2 cos squared single x subtract 1. So we could write this as 2 cos squared single x subtract 1 plus 1 all over, could we write sine 2x as anything helpful? Well, we could write that as 2 sine x cos x. So all over 2 sine x cos x. Now, the negative 1 and the plus 1 cancel, and the 2's cancel, and we've got cos squared over sine cos, which is cos x over cos x sine x. Cos's cancel, and we get cos over sine, which by definition is cot x, and we're done for 4 marks, and we've got our 8 marks for the question. Next question, pause the video, have a go. Okay, part A, we're trying to show the following. Okay, so why don't we just write the left-hand side? Actually, we should know a well, the left-hand side we can write as a difference of 2 squares. Okay, so let's have a go at part A. We're trying to show this is equal to cos 2 theta. There are many ways to do it. Let's just start off by writing out what the top and bottom means. The top, well actually let's just write the top. The top is 1 minus tan squared theta, which is 1 subtract sine squared theta over cos squared theta, which if we make the denominators the same, that would be cos squared theta subtract sine squared theta, all divided by cos squared theta. Okay, the left-hand side, that's the numerator. What about the denominator? Well, 1 plus tan squared theta, by a similar piece of algebra, would actually turn out to be cos squared theta plus sine squared theta over cos squared theta, which would be 1 over cos squared theta. So we have this, we have the numerator divided by the denominator. What we've got for the left-hand side, we therefore have cos squared theta subtract sine squared theta over cos squared theta divided by 1 over cos squared theta. Well, that's like changing that to a times and multiplying by cos squared theta over 1. So we'd have cos squared theta subtract sine squared theta over cos squared theta. The cos squared thetas would cancel, and we would get cos squared theta subtract sine squared theta, which by definition, or the double angle formulae, is cos 2 theta, which is the right hand side. And therefore we'd be done. B, hence or otherwise prove the following. Okay. We're asked to prove that tan squared pi by 8 is equal to this thing here. How can this help us? What I'm going to do is I'm going to copy this onto the next slide and just see how that might be able to help us. Okay, if we were to let theta in this equation be equal to pi by 8, let's just see what would happen. We would have 1 subtract tan squared pi by 8 over 1 plus tan squared pi by 8 would be equal to cos 2 times pi by 8, which is cos pi by 4. Now, therefore we would have 1 minus tan squared pi by 8 over 1 plus tan squared pi by 8, and we would have this is equal, well, cos of pi by 4 is root 2 over 2. Okay, now in theory, what we could do, I'm just going to make this a bit smaller now. put this over here, make it a bit smaller. What we could do now is we could multiply this out and get an equation and get something for tan squared pi by a and rearrange it and make it the subject, and hopefully it will equal this. So multiply both sides by 1 plus tan squared pi by a. We would get 1 subtract tan squared pi by a is root 2 over 2 plus root 2 over 2 tan squared pi by 8. So I could add 1 tan squared pi by 8 to both sides and subtract root 2 over 2. So I would get 1 subtract root 2 over 2 would be equal to 1 plus root 2 over 2 tan squared pi by 8, because I've got root 2 over 2 and I add another one. Now you should continue working down the page. I'm just going across for ease here. So therefore tan squared pi by 8 must be equal to 1 subtract root 2 over 2 divided by 1 plus root 2 over 2. Now let's see if we can actually work that out. This here, if I want to work out the top of this fraction, I would have to make the denominators the same. So this would be the same as 2 subtract root 2 over 2 divided by 2 plus root 2 over 2, which is the same as 2 subtract root 2 over 2 multiplied by 2 over 2 plus root 2. The 2's would cancel, so I would get 2 subtract root 2 over 2 plus root 2. But I wouldn't like to leave it like that. You should rationalise a surd, so I should multiply top and bottom by 2 subtract root 2. On the bottom, I would therefore get 4 take away 2, which is 2. On the top, I would get 4 subtract 2 root 2, so subtract 4 root 2 plus 2. So I would get 6 subtract 4 root 2 over all over 2, which is 3 subtract 2 root 2 if I divide everything by the 2, and I'm done. Okay, next question, pause the video, have a go. Right, first part, we are given this is true, we are told to prove this is true. Okay, so what we can do is we can expand the left hand side and we can expand the right hand side and we can make them equal, and hopefully we will get this. So therefore, if I expand this, I would get cos x cos 30 subtract sin x sin 30 must be equal to 3, expanding this, cos x cos 30 plus 3 sin x sin 30. Okay, what I could do now is I could add sin x sin 30 to both sides and subtract 3 cos x cos 30 from both sides. So this ends up sort of going there and that ends up going there. I'll get minus 2 cos x cos 30 would be equal to 4 sin x sin 30. Now you should know that sin 30 is a half, so that should have been a 30 here. And you should also know that cos 30 is root 3 over 2. So therefore this side would be a half times 4, which is 2 sin x, and this side would be negative 2 times root 3 over 2, which would be negative 3 cos x. Dividing both sides by cos x, so dividing everything by cos x, we would get that negative root 3 is equal to 2 tan x, and therefore tan x, as required, is negative root 3 over 2, and we're done for 5 marks. Next question. Prove the following is true. Well, we should know that cos of 2 theta by the double angle formulae is equal to 1 subtract 2 sine squared theta. We should also know that sine 2 theta is 2 sine theta cos theta. So therefore the left hand side, substituting this in, would be 1 subtract 2 sine squared theta, all divided by 2 sine theta cos theta, which would therefore be equal to 2 sine squared theta over 2 sine theta cos theta. The 2's would cancel. That sine squared is sine times sine. One of the sines would cancel, and you would get sine over cos, which, as you were looking for, was tan theta, which is the right hand side. Verify that theta is 180 is the solution of this equation. All we've got to do is stick theta is 180 in. So sine of 360, well, we know sine of 2 times 180 is 360. We know that's 0. We also know that cos of 360 is equal to, or the cos graph looks like this. So cos of 360 is equal to 1. So therefore, 2 subtract 2 cos 360 is 2 subtract 2, which is 0. So we have, this is our left hand side, this is our right hand side, left hand side equals right hand side, and they both equal 0. So you know 180 is a solution. Using the result in part A or otherwise, find the other two solutions to this equation here. Okay, so let's have a look back at part A and see what we did. In part A, we proved that 1 minus cos 2 theta over sine 2 theta is tan theta. So I'm just going to copy what we proved. We proved the following. And I'm going to drag that to the next slide. That's what we proved. Okay, so let's work with what we've got here. We've got sine 2 theta is 2 subtract 2 cos 2 theta. Okay, so what if we divided both sides by sine 2 theta? I would get 1 is equal to 2 subtract 2 cos 2 theta over sine 2 theta. Okay, what if I factorise the 2 from the top? And what if I divided both sides by the 2? I would get a half is equal to 1 minus cos 2 theta over sine 2 theta. Now look, something quite interesting has happened. This here is part of the result we used, or we found out in part A. So solving this thing here equal to a half is equivalent to solving tan theta is equal to a half. And if you do the inverse tan of a half, we may get ourselves the other solution. So the inverse tan of a half, making sure your calculator's in degrees mode, is 26. Theta is 26.6 degrees. Now, between 0 and 360, there's one solution there at 26 and another at 180 plus that, which would be equal to 206.6 degrees. And these are the other solutions to the equation that we were looking to find. Okay, next question. Pause the video, have a go. Okay, let's do part A. It gives us, helpfully, the addition formulae, the addition and subtraction formulae, sine A plus or minus B and cos A plus or minus B. It asks us to show the following. Easiest thing to do is just expand that using the addition formulae, expand that, subtract them, and hopefully you get this. So let's just do it straight away. Sine A plus B by above is sine A cos B plus cos A sine B. Sine A subtract B would be sine A cos B subtract cos A sine B. If you took these away from each other, so you got sine A plus B subtract sine A subtract B, what would you get? Well, taking these away, these two would disappear and you get cos A sine B subtract negative cos A sine B. So actually what you get is 2 cos A sine B, and you'd be done. Next, show the following. Okay, exactly the same thing we're going to do here. So I'm going to write out what cos A subtract B is. Cos A subtract B using the above formula must be cos A cos B plus sine A sine B. Cos A plus B must be equal to cos A cos B subtract sine A sine B. And if we take them away, we would have cos A subtract B subtract cos A plus B. Well, just looking at these columns, what would we get if we subtract them? Well, this one and this one would subtract from each other, and you get sine A sine B subtract negative sine A sine B, which would actually be 2 sine A sine B, and you've got what you asked for. Next, use the above results to show the following. Well, we have previously in part I worked that out, and in part I worked that out. So if we use those results and write one above the other, hopefully it will be clear to get cot A. So sine A plus B subtract sine A minus B was 2 cos A sine B. So we can write the top here as 2 cos A sine B. Cos A subtract B subtract cos A plus B, we've just done that. That's 2 sine A sine B. So that's 2 sine A sine B. So I'm going to call this the left-hand side. So left-hand side equals this, and we did this by part A. Now you will notice a factor of 2 cancels from top and bottom, and the sine B cancels from top and bottom. So this is simply equal to cos A over sine A, which by definition is 1 over tan A, which is cot A. And we're done. It's as simple as that. Okay, next, using the result of part B, find the exact values of sine 60 and cos 60, and the exact values of sine 60 and cos 60. Find cot 75. Okay, well we know from part B that cot of A is equal to sine A plus B subtract sine A minus B. So sine A plus B subtract sine A subtract B, all divided by cos A minus B minus cos A minus B minus cos A plus B. Okay, that's all we got from the previous part. Now we want to work out cot 75. Well, why don't we let A, therefore, be 75? This would help us work out what cot 75 is. But in order to here be able to evaluate these, we need to choose B very carefully so we can evaluate them. Well, why don't we choose B to be equal to 15 degrees? Then we would get sine of A plus B, which would be sine of 90, subtract sine of 60 over cos of 60, subtract cos of 90. And all these we can work out because sine 90 is 1, sine 60 is root 3 over 2, cos 60 is a half, and cos 90 is 0. So we are getting 1 subtract root 3 over 2 divided by a half, which is the same as 1 subtract root 3 over 2 multiplied by 2 over 1. And if we multiply out those brackets, we would get 2 subtract root 3. And that would be the exact answer of cot 75 as required. And we're done. We've got our 11 marks. Okay, next question. Pause the video, have a go. Okay, the first one's an identity. Show that for all values of x, this is true. Best thing to do would be to expand out the left-hand side. That would be sine x plus, using the addition formulae here, this would be sine 60 cos x subtract cos 60 sine x. So this would be sine x. Sine 60 is root 3 over 2, so we'd get root 3 over 2 cos x. And cos 60 is a half, so it'd be a half sine x. Just tidying those up. Sine x subtract a half sine x is just a half sine x plus root 3 over 2 cos of x. Now currently there's nothing much else we can do with this to make it look like this. So we could actually use the r cos, r sine theta formulae, etc. But it's a bit too difficult. I would at this stage just start off on the right hand side. Manipulate that and show that it is actually, after you manipulate it, equal to this. And then you know both sides must equal the same thing, so they are equal. So the right hand side, if we expand it, sine 60, 60 plus x, expand that using the addition formulae, you would get sine 60 cos x plus cos 60 sine x, and sine 60 is root 3 over 2, and you'd have cos x, cos 60 is a half, and therefore they are both equal. You can see very clearly that therefore left hand side equals right hand side. So left hand side equals right hand side, and you're done. Okay, next part. Given that sine 84 subtract sine 36 is sine alpha, deduce the value of the acute angle alpha. Okay, so we can look back at previous parts. Is there anything we can use from the previous parts? In the previous parts we had sine x plus sine of 60 subtract x equals sine of 60 plus x. Okay, so we could rearrange this and say that therefore sine x is equal to sine of 60 plus alpha subtract sine of 60 subtract x. Sorry, this should have been an x. And therefore, for alphas, this is just subtracting this off both sides. We could say that in theory, for any alpha, sine alpha is sine of 60 plus alpha subtract sine 60 subtract alpha. Now, if you let your alpha equal 24, then we would have sine alpha is equal to sine 84 subtract sine 36, just by substituting in 24 here. And we are told that sine 84 minus sine 36 is equal to this sine alpha. So what is the value of alpha? Alpha, therefore, must be equal to 24. Okay, so what I did to get this, I used the previous part, rearranged it, and then I chose an alpha to get exactly the sine 84 minus sine 36 on this side I wanted. Next, solve this equation for all values of x between 0 and 360, give your answers to one decimal place. Now, clearly, we're going to be using some form of the work we've done previously. I can see that that and that look a bit like what we've been doing in this previous part here. Okay, they look very much like that. So, what we can do is, so what I'm going to do is I'm going to go back to the previous slide and just take a copy of the thing we previously worked out. These questions always rely on previous working. So this is what we previously showed for any x. As follows. We previously showed that for any x. Now actually we are very close to having this here. If we just break this up into 3 sine 2x plus sine 2x, breaking this up here, plus sine of 60 subtract 2x, we write that, and then it's equal to sine 60 plus 2x from here minus 1. All of a sudden, this part here, sine 2x plus 60 minus 2x, looks very much like this here, apart from the x is doubled. So we can use this identity here and replace this by this. And we could say that is 3 sine 2x plus, here, sine of 60 plus 2x. And that would equal sine of 60 plus 2x, subtract 1. Now this makes life a whole lot easier because you could subtract sine 60 plus 2x off both sides, and you could divide both sides by 3, and you are solving the simplest of equations. Sine 2x is negative a third. To get 2x, your principal value, take the inverse sine of negative a third on your calculator in degrees mode. So inverse sine of negative a third should give you a principal value of negative 19.5 to 1 dp, but that's not inside our range, but that doesn't matter because we'll just draw our range out here. Now, because we've got 2x, we're going to double everything, so I'm going to slightly go beyond this side, so (180, 360, 540, 720). So negative 19.5 is somewhere here. So I'm going to have a solution here, 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 and here. And where are those points? So 2x, just extending the page, would be 180 plus this. It would be 180 plus 19.5. It would be 199.47. Another one here would be 360, subtract that, which would be 340.53. And then there will be another one here, which will be, that would be 540 plus the 19.5, which would be 559.5, and there'd be one other one, which would be actually equal to that, would be 180, 360, 540, the 720 would be there. It would be 720, subtract 19.5, and it would be equal to 739.5. If we half everything, then what would our answers be? Sorry, this one here, this last one, was 720, subtract 19.5, it was actually 700.5. So halving these, 199.47 divided by 2, be 99.7 degrees. This one would be 340.53 divided by 2, 170.3. This one would be 559.5 divided by 2, which would be 279.7 degrees. And the last one would be 700.5 divided by 2, which would be 350.3 degrees. 350.3 degrees. And that's it. We're done. Next question. Pause the video, have a go. Right. It tells you explicitly by writing sine 3 theta as sine 2 theta plus theta, show the following. So, sine 3 theta, it tells you to write that as sine 2 theta plus theta. Then you can use the addition formulae, the sine A plus B formulae, which tells you that this is equal to sine 2 theta cos of single theta plus cos of 2 theta sine of single theta. Okay, but you should also know, here's some work, that sine 2 theta is 2 sine theta cos theta. You know your final answer is just going to have sines in it, so you should also use the fact that cos 2 theta is 1 minus 2 sine squared theta. You should know those. So substituting in for sine 2 theta as this, I would have 2 sine theta cos theta, and then I would have my cos theta here, plus subbing in for this, I would have 1 minus 2 sine squared theta multiplied by sine theta. Okay, then I can multiply it out. This would be equal to 2 sine theta cos squared theta, and multiplying this out plus sine theta subtract 2 sine cubed theta. Now, it's not in the form I want. Everything has to have sine, so I can replace this by 1 minus sine squared. So 2 sine theta, 1 minus sine squared theta, plus sine theta minus 2 sine cubed theta. Expand that out, I get 2 sine theta, subtract 2 sine cubed theta, plus sine theta, subtract 2 sine cubed theta. And now I can tidy everything up. I've got 2 sine theta here, plus a sine theta here, which is 3 sine theta. And I've got myself a negative 2 sine cubed theta here and a negative 2 sine cubed theta here, which is negative 4 sine cubed theta. And I have shown what they asked me to. Okay, next part. Given that sine theta is root 3 over 4, find the exact value of sine 3 theta. Well, from the previous part, we have an expression for sine 3 theta. And it is 3 sine theta subtract 4 sine cubed theta. So 3 sine theta subtract 4 sine cubed theta. But we also know that sine theta is root 3 over 4. So it's just simple substitution. Substituting in, we would get 3 multiplied by root 3 over 4. We would get subtract 4 multiplied by root 3 over 4 cubed. Well, this first one is simply 3 root 3 over 4. This one here, I'm going to leave the 4 there. Root 3 times root 3 times root 3 is actually 3 root 3. And 4 times 4 times 4, I'm just going to currently write as that. Now, one of these 4's would cancel, and that would be 16 on the bottom. So really what we're dealing with is 3 root 3 over 4 subtract 3 root 3 over 16. And if we want to add fractions, make the denominator same, times top and bottom here by 4, I would get 12 root 3 subtract 3 root 3 all over 16, which is 9 root 3 over 16. If we had typed that straight into our calculator, we'd have probably got this answer. So if your calculator does that, but if your calculator doesn't, to find the exact values, you've got to be able to work with surds. Okay, next question, pause the video, have a go. Okay, you'll notice this is very similar to the question above. It's using the same ideas. So it says, writing 3 theta as sine 2 theta plus theta, show the following. Now you should be able to do this. We've just done this. So we're working out sine 2 theta plus theta, and we're saying that by the addition formula is sine 2 theta cos theta plus cos 2 theta sine theta. Now, do you remember the identities I said you must use? Well, you must use that sine 2 theta is 2 sine theta cos theta. You must use the identity that cos 2 theta is 1 minus 2 sine squared theta. And later on, you use the identity that cos squared theta is 1 minus sine squared theta. So all these 3 identities are going to be used. At first, we're going to use this one and this one to substitute in for sine 2 theta and cos 2 theta. So we get 2 sine theta cos theta plus 1 minus 2 sine squared theta sine theta. Multiplying out, that's 2 sine theta cos squared theta plus sine theta minus 2 sine cubed theta. And then we're going to replace cos squared theta by 1 minus sine squared theta. So we would get, multiplying that out in one go, 2 sine theta, subtract 2 sine cubed theta, plus sine theta, subtract 2 sine cubed theta, and therefore we would get the 3 sine theta, subtract 4 sine cubed theta that we're after in the question, and we're done. Okay, next part. Hence or otherwise, for theta between 0 and 2 pi, solve the following. Give your answer in terms of pi. So, how does the following relate to what we've done? So let's take a look back. We know that sine 3 theta can be written as this. In fact, what might be easiest is if you always write down what they've done in the previous part. It might make it easier for you to identify what to do in the part you're working on. So that's what we've showed in the previous part. Okay, is there any way we can use this identity here? Well, first of all, I think we can. If we just subtract 1 off both sides, so 8 sine cubed theta. Actually, why don't we, instead of that, why don't we subtract 8 sine cubed theta off both sides and add 6 sine theta to both sides? So I get 1 would equal 6 sine theta, subtract 8 sine cubed theta, right? Now the reason I did that is I know that I've got a positive sign here, I wanted a positive sign there, and a negative sign cubed here. So that's why I did that way round. Now look, if with a bit of magic, if you actually factorise out a 2 there, look what you get. You get this here. Where have you seen that before? Well look, it's there. So actually you could replace this by sine 3 theta. So this is the same as 1 equals 2 multiplied by sine 3 theta. So this is like a half, dividing both sides by 2 is equal to sine 3 theta. And that's what you're solving. So to get 3 theta, you take the inverse sine of a half, and between 0 and pi by 2, the inverse sine of a half is pi by 6. So 3 theta is pi by 6. You want to work out any other thetas that might help you. Well, you're going between 0 and pi by 3, but because you've got triple the angle, you're going between 0 and pi. 0 and pi looks like this for sine, and you know there's one answer here, pi by 6, so there'll be another answer at pi subtract pi by 6, which is 5 pi by 6. So there'll be another answer, 5 pi by 6. That was 3 theta. What therefore is theta? You divide both of them by 3, so therefore theta is pi by 18 and 5 pi by 18, and you're done. Next, by using the following identity, show that sine 15 is equal to this. Okay, so they're telling you to use sine of theta subtract alpha is equal to sine theta cos alpha subtract cos theta sine alpha. Can we choose theta and alpha in such a way to create 15 on this side? So when you take them away, you get 15. But so that when they're on their own, they're angles we know about. Well, we could. Because what if theta was 60 and alpha was 45? Then indeed we would get sine of 15 degrees. And it would be equal to sine of 60, which we know, cos of 45, which we know, subtract cos of 60, again we know, sine of 45, which we know. So sine 60 is root 3 over 2. Cos 45 is root 2 over 2. Cos 60 is a half, and sine 45 is root 2 over 2. So this is equal to root 3 times root 2 is root 6 over 4. 1 times root 2 is root 2. Subtract root 2 over 4. And factorising out the quarter, we get a quarter root 6 subtract root 2, and that's it. We got it. And there are 13 marks in the bag, nice and easily. Okay, next question. Pause the video, have a go. Okay, have a look. Right, let's work through this new question. Use the double angle formulae and the following identity to obtain an expression for cos 3x with only cos x's in it. So it's like we did with the sine x, so cos of 2x plus x, that's the way to start these off. Using this, that must be equal to cos of 2x cos x, subtract sine of 2x sine x. Now, we're supposed to use some double angle formulae here. We want everything in terms of cos x, so I've got a cos 2x here, so the double angle formula I'm going to use for that is equal to 2 cos squared single x subtract 1. And for this sine 2x, well, there is no formula for it just in terms of coses. It is simply 2 sine single x cos single x. So let's sub those in and see what we get. We would get 2 cos squared x subtract 1 multiplied by cos x, subtract 2 sine x cos x multiplied by sine x here. Multiply those brackets out, we get 2 cos cubed x subtract cos x. And then here we would get subtract 2 sine squared x cos x. Now you should also know that sine squared single x is 1 minus cos squared single x. So sub that in, 2 cos cubed x subtract cos x, subtract 2, 1 minus cos squared x cos x. So 2 cos cubed x minus cos x. Multiplying this out here, all in one go, let's try and do it. You get subtract 2 cos x plus 2 cos cubed x. So collecting everything, you've got 4 cos cubed x, subtract 3 cos single x. And that's it. You've obtained the expression for cos 3x that you were looking for. Next part, prove the following. So you have to prove the following is true. This is equal to 2 sec x. Well, probably the best way to do it is start on the left-hand side and then try and make it equal to 2 sec x, because starting with sec it's hard to manipulate a simple expression into something more complicated. So let's go for more complicated and make it simple. So we've got on the left-hand side, we've got cos x over 1 plus sine x plus 1 plus sine x over cos x. Now we're trying to add fractions, so if we want to add them, make the denominators the same. The denominator, the best denominator, would therefore be cos x multiplied by 1 plus sine x. So this one needs times in top and bottom by cos x, so you get cos squared x. This one needs times in top and bottom by 1 plus sine x, so you get 1 plus sine x all squared. Right, let's expand that. You would get cos squared x plus, you would get 1 plus 2 sine x plus sine squared x, all divided by cos x 1 plus sine x. Okay, doesn't look helpful so far, but cos squared plus sine squared are 1, and you've already got a 1 there. So this is, the top would be 2 plus 2 sine x over cos x, 1 plus sine x. You could factorize the top, factorize out a factor of 2, 1 plus sine x over cos x, 1 plus sine x, and then that's where the magic happens. The 1 plus sine x cancels, and you get 2 over cos x, which by very definition is 2 sec x. The reason, it's not asking about this, but the reason x can't be that is because this would make the bottom at 0, which it can't be, but it hasn't asked you to show that, it's just stating a fact. Next, hence, we're asked to find all the solutions to the following equation. Well, we know this is the same thing as writing 2 sec x is equal to 4 from the previous part. So this is like writing 2 over cos x equals 4, which is the same thing as the following. So what we can do is that we can flip both fractions, and we could say that cos x over 2 is equal to a quarter, and times both by 2, cos x is 2 over 4, which is a half. So we're finding all solutions where cos x is simply equal to a half. Well, x is therefore the inverse cos of a half, and that is equal to pi by 3. So let's find all our solutions between 0 and 2 pi. We know the cos graph looks something like this. That point there is pi by 2, that point there is pi, that point there is 3 pi by 2, and that point there is 2 pi. Now we have one solution which is pi by 3 away from the tip, so we're going to have another solution that's pi by 3 away from the tip there as well. So that would give us, the other solution must be 2 pi, subtract pi by 3, which is 5 pi by 3. And they are our x's, and we're done. Okay, last question in this series. Pause the video, have a go. Okay, let's work through this. We are told that cos A is 3/4. And more importantly than that, A is between 360 and 270. That's a very important fact for us. We're asked to find the exact value of sine 2A. Now, we know that sine 2A by the double angle formulae is 2 sine A cos A. Now, we know cos A, so we're covered, but we don't know what sine A is. So the first thing we probably need to do is work out what sine A is. Now you should know the following, that sine squared A is 1 minus cos squared A. So sine squared A is therefore 1 minus 3/4 squared. So sine squared A is 1 minus 9 over 16. So 1 subtract 9 over 16, which is 7 over 16. So therefore, sine A is the square root of this. So sine A is either plus or minus the square root of 7 over 4. Now the question is, which one is it? Is it the positive square root of 7 over 4 or the negative? To think of that, we know our A angle is between 270 and 360. So we just need to think of the sine graph at these points. The sine graph between 270 and 360 is certainly negative. See, it's certainly negative there. So we're going to take the negative value. So therefore, I'm just going to make this all a tiny little bit smaller. We are certainly going to take the negative value for sine A. So sine A is going to be negative root 7 over 4. Okay, therefore we can work out, I'm going to work across the page, you should work down the page. Therefore we can certainly now work out sine of 2A. So sine of 2A is 2 sine A cos A, which is 2. Sine A is negative root 7 over 4, Cos A is 3 over 4, and if we multiply those things together, we would get negative 3 root 7 all over 8. And then we're done. Next part, show that the following is equal to cos 2x. This will be a simple application of the addition formulae. Remember the addition formulae for cos? I'll just write it down. It tells us that cos of A plus or minus B is equal to cos A, cos B, subtract or plus sine A, sine B. So what we're going to do, we're going to work this, this one out. We're then going to work this one out. We're going to add them together and hopefully we get that. So I'm going to do it on separate lines. Cos of 2x plus pi by 3. Well, that is cos 2x, cos of pi by 3, subtract sine 2x, sine pi by 3. And cos of 2x subtract pi by 3 would be cos of 2x, cos of pi by 3, plus sine 2x, sine pi by 3. So now if we added these, put a line under them and add, we would get cos of 2x plus pi by 3 plus cos of 2x subtract pi by 3. Well, hopefully you can see this one and this one will cancel and we get 2 lots of this one. So we get 2 lots of cos 2x, cos of pi by 3. Now you should know cos pi by 3, that's like cos 60. Cos 60 is a half, and a half times the 2 would just give me 1. So this is therefore equal to cos 2x as required. Next, given that y is equal to this, show dy by dx is this. Okay, this is the last part. Now, you should be thinking, how can I use the previous part here? Look at that. That looks awful similar to this, and we know it's equal to cos 2x. So a simpler way of writing y is to say that y is actually 3 sine squared x plus cos 2x. And that is so much easier to differentiate. Therefore, dy by dx, by the chain rule here, you've got your 3, bring down the power of 2, differentiate the sine x to get cos x, and then write the sine x to 1 less power to the power of 1, plus cos of 2x. Well, this is 3. Sorry, we haven't, my apologies here, sorry, I forgot to differentiate the cos 2x. The cos 2x differentiates to, differentiate the brackets, you get 2, differentiate the cos, you get negative sine, and keep 2x there. Okay, so this differentiates to 6. Again, sorry, there's one thing you could do here. You could notice that 2 cos x sine x is actually sine 2x. So this is like 3 sine 2x, okay, minus 2 sine 2x, which is equal to 1 sine 2x, which is what you were looking for. And we're done. And they are all the questions that have ever come up on trigonometry using the addition and double angle formulae. I hope you found it useful for revision. Thank you for watching.